Okay, like I said, we're going to be talking about some pipe monitoring, and in a similar format, we're going to start with the single wall lines. It's what you might think of as chronological order. So you're going to have your single wall lines, and then double wall, and then, of course, like I mentioned earlier, we're going to talk about VPH systems as a whole after this section here. Okay, this looks confusing, huh? A lot of information. Anyone familiar with this chart or table? If not, then you should be. It's excellent. This is a table, you can find it on the state website, and it basically gives you a breakdown of the different monitoring types depending on the type of situation you have. So for example, you have your requirements for pressurized piping, you have your emergency generator tanks, or generator piping, that's going to have different monitoring requirements. Your suction systems, whether it be conventional or safe suction. And then, of course, those few gravity-fed lines out there. Okay, so I'm going to tackle each one of these separately, which I hope will make it more clear. And like I said, this table is it's on the state website, and maybe during a break I'll try and get that link out there for you. But this is page 5. It's just about a 7-page document that really gives a breakdown of law and regulation, make it easy to travel with. Okay, so first we're going to start with probably the most common type of single wall piping, which is going to be your single wall pressurized piping. And don't forget, unless I say otherwise, we're strictly talking about the piping here, not the tanks anymore. Okay, so a lot of words, but I'm just going to give you a basic breakdown so we keep it clear in our heads what's going on. So with single wall pressurized piping, you're going to need an automatic line leak detector. Are you guys familiar with those? Yeah, if not, we have some pictures coming up. We were going to bring one, but they're quite heavy, so we decided not to do that. So with a single wall line, when the line leak detector goes into alarm, it's going to need to shut down the product. Okay, keep in mind that we're dealing with single wall pressurized piping, so it's a greater risk than some other potential situations. Okay. Additionally, so keep in mind, the line leak detector is a piece of equipment that remains on the tank system at all times. And then in addition, you're going to need a 0.2 monthly line test. And what that means is you need to do a line test every month that has a leak threshold of 0.2 gallons per hour. So you're looking for a leak that's going to have that rate. It should catch something at least 0.2 gallons or higher of a leak rate. Okay, or instead of doing a 0.2 monthly test, you have the option of doing a 0.1 annual test. Okay, so the leak threshold is smaller, but you're also doing it less frequently. Okay, so just a quick summary. You're looking at an automatic line leak detector, which is going to be a permanent fixture on the system. And because it shuts down product or the pumping action, it's going to be an electronic line leak detector, because otherwise there's no signal back to the monitor console or the relays. And then we'll have pictures of all those. Okay, so then the option of an integrity test, whether it be monthly or annually. Okay, any questions? No? Okay. Okay, like I said, here's some visuals just to give you an idea for those of you that are still new to these types of systems. They're all capable of detecting a 3-gallon per hour leak, so I know you're hearing 3-gallon, 2-gallon, 1 gallon, what's going on. So keep in mind when I referenced the monthly and the annual tests earlier, those are integrity tests. This is just a threshold for these automatic line leak detectors. Okay, so your options are either restricting or shutting off the flow of fuel. So the left hand, you're going to have a mechanical line detector, and that's going to restrict the flow. And what that really means is if you're dispensing fuel into your car, it's going to start slowing way down. It's still going to be pumping, but it's going to slow way down, noticeably. And then if you have an electronic line leak detector, it's going to shut off the turbines if it detects a leak. Okay, so that's electronic, and it's going to be wired into your monitoring panel. So So what's an easy way to tell electronic line leak detector between mechanical? Yes, very good. So you're always going to have some sort of connection point. It's going to need electricity. It's going to need that connection to the console. Excuse me. So, like I said, that was single wall pressurized piping. That was the monitoring options. So they've broken down the piping associated with an emergency generator system into both pressurized and suction systems. Okay, so they have it together, and mind you, this is line that is feeding an emergency generator as part of that system exclusively. So your requirements for that are actually going to look fairly similar as the single wall pressurized system. So when we're talking about the pressurized lines for an emergency generator tank, you're going to find the same requirements as you did for non-EG tanks, okay? So once again, you're looking at a line leak detector. Keep in mind, the difference between emergency systems and a pressurized system is, although they need a line leak detector, it does not need to shut off the flow of product. However, it still needs to indicate a leak via audible visual alarm. So once again, you're still going to need that electronic line leak detector, because that's what's connected to the console. Okay, and then like the previous slide, we have your options between a 0.2 gallon per hour integrity test or a 0.1 annual test. Okay, and then like I said, pressurized system, and then still within the realm of emergency generator tanks, we have suction. And this just has one option that's required by third party, which is going to be a 0.1 gallon per hour integrity test, and that's going to be triennial. So that's every 3 years, not 3 times a year, so that's good. And then of course, you're going to want daily and visual monitoring by the owner-operator. Okay, and just to be clear, there's some specific language that determines if you're dealing with an emergency generator tank. And it becomes important because you have different requirements for the lines. You have different requirements for the above ground piping associated with these systems. So it's clear, it needs to be distinct. So the definition for emergency generator tank system is given that it's a tank that provides power in the supply, or power in the event of a commercial power failure. So basically, it's your emergency generator tank, right? So, and it needs to be connected solely to the emergency system. You know, if it's connected to other aspects of the property or the facility, it very well could take it out of that status. Okay, we're still dealing with single wall piping, don't forget. So now we have conventional suction piping. How many of you are familiar with conventional suction piping? 1, 2, okay, good. More than 0. So conventional, what does that mean? That's a good way to describe it. In terms of the single wall piping, you're going to need to do a 0.1 gallon per hour triennial line test, and that only needs to be done every 3 years as well, okay? And then you're going to have a daily visual monitoring. So this is the same as for emergency generator tank systems for the suction lines, right? So it's pretty standard. And then, just to give you a little background, it seems to be a new term for a lot of us. It's operating at less than atmospheric pressure. There's no submersible turbine sump. And the distinction between conventional suction and then the type of system I'm going to talk about next is that there's going to be some sort of valve in the piping. You're either going to have a foot valve or an angle check valve. And the significance of that is that these valves are within the piping that's below grade, and that's going to hold fluid in those lines on a permanent basis. Yes?
Would you mean no submersible turbine pump instead of sump?
Yes. You get a candy for that. Thank you. You don't know how many times I've looked at this presentation, so thank you. Yes, so no submersible turbine pump. Okay, like I said, the issue with these is they have a valve within the line. So at some point, whether it's halfway through the line or at the bottom, they're going to have something that's maintaining that liquid within the pipe at all times. So here's a visual to let you know what I'm talking about. You have your dispenser here, and then if you follow the product line right here, your options are either going to be an angle check valve here at the top or foot valve. You could probably figure out why it's called the foot valve. So depending on which one you have, whether you have an angle check valve, which means you're going to have continuous holding of product in this section of the piping. Mind you, this is all underground piping. And if you have a foot valve, you're going to have this entire line filled up and ready to go. So it's a bit more of a risk. Which brings us to the next type of suction system, which they have termed to be single wall safe suction. Okay, and the main difference, and you notice it looks like they have a lot more requirements, but really the main thing is that they're saying there's really no requirements if all the criteria are met, which they're going to be met if you're considering this to be a safe suction piping. Okay, so it basically tells us it doesn't have anything that you would have for the conventional suction. So, oh, turbine sump again. Okay, so there's no submersible turbine pump. Also, you're going to be less than atmospheric pressure, and then the main difference is there's no check valve in the piping. So just to give you a visual on that, you're going to find a check valve, if at all, it's going to be above ground, most likely right at the dispenser. So that means you have an unobstructed flow of product fuel. So when you're done pumping or sumping, you're going to have the fuel go back to the tank, and you're never going to have any standing fuel. Okay, and this is just an overview of what a sump looks like. That, you know, it's good indication that you have a suction system. You have a sump but no pump. Come on, guys, that was funny. But you do have a suction pump in the dispenser, so that's going to create the suction. Okay, so our last option under single wall piping is your gravity piping. You know, very minimal risk. However, they still need, let's see, a 0.1 gallon per hour biennial line test. So every 2 years, they're doing a line integrity test if you have single wall gravity fed piping. So for example, a remote fill line might work on gravity. So it seems like not much, but they're still going to need to get that testing done every 2 years. Okay, any questions on the single wall monitoring? No? Okay. So moving on, we're going to talk about double wall piping. So the important date for double wall piping is post 87. So keep in mind, tanks were required to be double walled post 84, but piping wasn't required until after 87. So this is just to give you another schematic of why secondary piping works in terms of leak detection. Okay, so you have your sump, you have your primary tank, your double or your secondary tank, and at this point you have a sump that's surrounding the sensor there, right here. And then ironically, the way you're monitoring this pipeline is at the sump. So at first it doesn't make sense. You're like, well, I'm monitoring the pipe, I'm not monitoring the sump, which is actually true. But the idea is you have this opening here. Your secondary pipe has access to that sump. Okay, so if you have a leak, whoops. If you have a leak in that primary line, where's it going to go? It's going to go in the secondary pipe, right? Then that leak is going to flow right into the sump and go into alarm, and then go into alarm. Okay, here's just a more real-life view just to show everything. Oh, and then something to keep in mind, too, is at construction, this is something that we should be verifying, or at least getting some documentation from the contractors, is that this piping is always going to slope toward the sumps. You're never going to have piping that slopes toward a UDC, so it's always going to go back toward the tank farm. And there's specific requirements with, I think it's every foot, 1/8 of an inch slope. I'm not entirely sure, but if you see an open tank farm at installation, it's pretty distinct that you can get that slope. Okay, so here's just a real-life view of a sump. And just to show, you have the secondary line, you have your primary line, and you have this opening here. Okay, so if you were to have a leak coming out of that primary pipe, it's going to come out right here. Then pretend there's a sensor right here. It's going to catch that leak at the first opportunity. Okay, and we're going to talk a little bit more in detail about secondary containment testing, but I'll just point out, since we have this picture, and we might have the picture again, but this boot here, you might wonder what it is, and this is actually a test boot for when you do secondary containment testing. And the idea is when you're not doing testing, which you need to do every 36 months, this boot needs to be pulled back so you have continuous, unobstructive ways of the leak coming into that dispenser, or sump, rather. Okay, is this a familiar sight to a lot of you? Yeah? Okay. Okay, so here's just some examples of double wall fiberglass piping here on the left. And then we have some flex piping. So here's a nice view of, this is rigid piping, fiberglass. So you can see a nice view. You guys see all that? So you have your double wall and you have your primary. And then, like in that previous picture, you have this reducer that's going to kind of seal out that secondary. So that helps you test the lines, and it also helps you test the sump. So you're not going to have any liquid going back and forth. And then here's an example of some flex piping. It's hard to see with this little white spot. This is the access point of where the secondary is open to the sump. And the interesting thing to note with the flex piping is that they have a very, very small interstitial space, which you think would be a problem, but it's not, because since it is so small, the pressure will send that fuel right through. So assume this is somewhere else, but then this is what comes into the sump, and this is where it would leak out of if they was a primary piping. Okay, so these will be up here the whole day, so if you guys want to come up at any time. Okay, here's a quiz question, and this is definitely for Candy, but can someone tell me the date range that this system was installed? 98, does the 98 work? 98 works, yeah. Can you tell me why? Well, wait, I heard Mustafa. Yep. No, absolutely right. So like I said, this is fiberglass piping. And if you notice, most of these lines are double-walled. And the reason you can tell they're double-walled is they have these blue clamshells. Okay? They're going to be a lot bigger. But here you have a single-wall line. So that means it must not have been installed prior to 2003. Because that's when the piping definition changed to include vent lines, vapor lines, and fill pipes. Okay, so that's a good indication. It's post-87, because you have your double wall product lines, but it's pre-2003 because you still have a single wall vapor line. Okay? We'll come up for Candy and Mustafa. Okay, is that clear? Does that make sense and kind of ties together what we were talking about earlier? Okay. Okay, so page 6 of that table is monitoring requirements for double wall piping. And keep in mind, this is double wall piping installed prior to July 1st, 2004. And once again, I'm going to go through this piece by piece just so it's a little bit more understandable. So double wall pressurized piping. This is probably our most common type of piping and type of piping monitoring. So hopefully, this looks like a lot of words, but hopefully we can break it down and make it more detailed for you all. Okay, so Like I said, double wall, so you're gonna have secondary containment. So the secondarily contained pipe has two options, okay? They can be continuously monitored by a sensor that activates an audible or visual alarm. Or the other option is that the continuous monitoring system will stop the flow of product at the dispenser. So does this make sense? This option here, you're gonna activate an audible and visual alarm. So if you get a leak in a sump, you're gonna activate that Veeder-Root or your Ronan or what have you, whatever product console you have. Okay, and the reason they give you an OR is that they're taking into account that some UDCs have mechanical methods of leak detection. If you guys remember from Zoraida's portion of the presentation, you have your standalone sensors, which are electronic, but they still only relate to that dispenser, and you also have the floats and chains. So this allows you to continue to monitor those UDCs with mechanical methods and still be in compliance. Okay, is that clear? Okay, but keep in mind, you can still monitor that UDC electronically and have it still be connected to the audio-visual alarm. Okay? Okay, and then also the other requirements include you also need to have a line leak detector, and that's been a requirement for all systems since, I think, November 9th, 2004. And then, of course, you need to have an annual 0.1 gallon per hour piping test. Does that sound weird to anyone? Do you guys see many 0.1 gallon per hour piping tests on double wall piping? Yes, no? Yes? No. The reason I bring that up is that there's an option. In lieu of a 0.1 gallon per hour test, you have an option. You can have positive shutoff, okay, for the turbine sensors, and you need to have fail-safe. Does that sound more familiar? Okay, and it's confusing because at times you think that's a requirement. You think they must have positive shutoff, they must have fail-safe. But that's only true if you're doing that in lieu of a 0.1 gallon per hour line test. Okay, and just to give you a little more details, the continuous monitoring must shut down product, meaning the turbine's going to be shut off when you detect the leak, and you're going to have what is termed fail-safe. Okay, just to give you a little more details on that. Basically, when a monitoring system, when it detects a leak, in the event of a power outage, or if someone physically pulls power to the monitoring system, it's going to also shut off the turbines. Okay, so it's very important to keep in mind that these in and of itself are not the requirements. The real requirement is a 0.1 gallon per hour line test, but what many stations do is they do those other two options in lieu of that 0.1. So an example of, perhaps they are doing a 0.1. So maybe an example of a local agency being more strict than what's required of the law is they might have a 0.1 gallon per hour, but that agency might still require positive shutoff. So it's not in the law, it's not in the regs, but it's still a requirement that a certain CUPA felt necessary to include. So that's an example of that as well. Okay, so here we have emergency generator systems again, except this time we're dealing with double wall piping. And same thing at the top, you have continuous monitoring that's going to activate an audible visual alarm, or you're going to have continuous monitoring that stops the flow of product when a leak is detected. Okay, and you're going to have continuous monitoring system checked at least daily with a log, of course, and you're going to have an annual 0.1 gallon per hour piping test. So what's missing? There's no line leak detector, right? I'm not for certain, but I believe it's missing because you're dealing with an emergency system. You don't want a functional piece of equipment to somehow go down or get messed up during an emergency. So they did require it for single wall tanks or single wall piping. I believe that's more of a risk when it's pressurized piping for single wall, but you're dealing with double wall piping now. So that requirement was removed for this type of monitoring. Okay, and then remember earlier in the day we brought up the fact that if you have emergency generator piping that's unburied, that's exempt from regulation. So what will normally happen in that situation is that you'll have the underground piping that runs from your tanks to the transition sump is what needs to be monitored. And then of course everything above ground is going to be exempt unless you have another agency that needs to get involved, such as fire code. Okay, so now we're back to suction and gravity piping, and two options here, either or. So you're looking at either activating audible visual alarm or stopping the flow at the dispenser. So you're seeing a lot of these same options repeated. And that's why this table is so great, is that you can really break it down. If you're looking at an emergency generator tank system and they're single wall, it's just a quick peek of everything you need, and it'll also send you to the sections in Title 23 for the details. Okay, just wanted to, you've seen some of these pictures already, but these are methods of continuous monitoring. Like I said, they require to be plugged into an audio-visual alarm, such as that console here at the top. And then, of course, your, another example is right to show you this sensor, another example of continuous monitoring that's electronic. And then the pictures at the bottom show the options for a mechanical method of stopping the flow, okay? So do you guys want to see this again? So this is a float that actually is what is literally doing the continuous monitoring. When that float goes up, this is what sends the signal to the console for either shut off or alarm. Okay, and then just something to mention, you have discriminating sensors and non-discriminating sensors. Most sensors we see are non-discriminating, which means this float is not going to know if it's being raised by fuel or water, okay, which means it's non-discriminating. And then some sensors are also programmed to detect what type of material it's picking up, whether it's fuel or water. So they might show an alarm for water or fuel. And for example, you have this one right here, and they have it. I don't know if you all have ever seen this in the field, but it's got a little blue piece of film, it looks like, and it's really actually detecting the vapors of the fuel. Okay, and then another brand we have here, they have little nodules that it's electronic, but it's also going to make that distinction between fuel and water. And we don't have any other pictures. Okay, so here, oh yeah, we do. So here's another example of a continuous monitoring electronic, mind you. I believe this is a Ronan sensor, and this is, I'm going to assume that this sump is flat, because if it's not flat, you're going to want your sensor on this side. Any guesses why? Right, so if you're having a piping leak, you're most likely going to have it on the side where the product piping is coming out of the turbine. And the reason why I say it could be flat, it may not be flat, is that some corporations have actually made their sumps, retrofitted their sumps and made a completely flat sump, whereas some sumps you see follow the curvature of the top of the tank. So you are going to have, you know, a preferred low point. Because for example, if this did have that curvature and you had the leak come out this way, this whole kind of crease would have to fill up, rise enough to get over to the other side, and then to fill up before it would even get to that alarm. So it's not going to get at the earliest opportunity. So here's just another, you can see the flow right through there. So this is a Ronan sensor. once again, just that picture of the emergency generator pipe that would make that exemption. Okay, what are some potential issues that you all have seen in the field without looking up there? Nothing? Look up there now.
One of the problems I find with floating chain setup is that
Disaster.
the price.
Yeah.
Because the spider webs, any debris gets in them, stops before work. In fact, I got one station changed down before.
Yeah. So this gentleman is pointing out he's seen a lot of issues with float and chain sensors, which, you know, sometimes the chain is missing, sometimes it's so sticky and corroded, no matter how much water you pour in there to do a functional test, it's not going to come up. So, you know, those are older systems when you see those. And like you said, you've got the spider webs. Nobody likes to get in there. I'm hoping things are better since 2005 with the designated operators that should be doing these monthly checks in the dispensers. And then I know in the more recent future, we've been doing more of a typical functional testing of them where they will actually fill that area with the float and chain with water to simulate a more realistic leak, as opposed to just, you know, moving the shear valve to make it pop. So I think that's helped quite a bit with maintaining compliance. Yes, Keith?
What are you doing with sensors that get stuck down there? The guy's saying, the only way I'm going to get this up is to rip it off. Like the bell's stuck.
Yeah.
You know.
I mean, they need to get it out. I personally haven't come across one where they just could never end up getting it out, but I mean, they need to have a functional sensor down there. And
It's going to be functional once they rip it out, and they don't have one with them to replace it.
oh no, well, that might be a local jurisdiction of how you handle that, but one option, to me, an annular sensor is a little bit more stringent. In the past, when we've had situations where they had to leave a site, whether situation like that where the sensor came out, but basically if they have to leave a site without an annular sensor, we usually have them shut down that product. So, but they usually get that fixed right away. Or what often happens is that you have one group on site with you, and then they call in other people in the company, and they're usually able to fix those types of things, you know, by the time you leave your inspection. So, if that sensor is broken when you get on site, do you have socks? Yes? No. So remember, when you get there, if it's not functioning, it's not in significant operational compliance. So even though you might leave the site with it fixed, when you arrived, which is the EPA standard, when you arrive, that was not, you know, that was not working correctly. So just tying it back in. Okay, so other things we've seen have been tampering. It's hard to prove sometimes, but it happens, and sometimes it's more obvious than other times. You might find a raised sensor, or you might find a sensor that looks perfectly wonderful in the sump, but it's not even connected to the monitoring system. And then, of course, ignored alarms. Some people, it's just an annoying little beep going off in the, you know, the other room. So all things that we usually see on site, so also things to look out for. And that's why also, if we do coincide our inspection with the monitor with the contractor, we allow them to be prepared to do the inspection, but not to move any of the sensors, because we want to see everything as is once we arrive on site. Okay, so any problems here? Raised sensor, yes. So you see here, you've got this gap. Should be in there. I mean, it's a nice little holder, right? Can you guys see it over here? Oh, you got it? Okay. So this looks like a perfect raised sensor opportunity. It's a good visual, but ironically, they're doing secondary containment testing, so that's why the sensor's pulled up. You'll notice here they have that boot on. And like I said, we'll talk more about secondary containment testing in a little while. But that's just to give you a visual. I mean, that looks actually pretty good. We've seen stuff where the sensor's, you know, all the way tied up at the top of the sump, and it's just a mess. Oh, there's the problem. No? All right, let's wake you guys up after lunch. What is the difference between a safe suction system and a conventional suction system? That's right. You're not going to have any sort of valve in there that's going to prevent the fuel from going back to the tank. Okay, so what type of piping is excluded from the definition of underground storage tank? Above ground what? That's right, emergency generator. Can anyone think of another example? One? Marina piping. Do you remember from before? Okay. See, what type of piping systems require an automatic line leak detector? Yeah, so that's just a more general description. You're looking at a pressurized system. The exception being that emergency generator piping that has the double wall. And at times, you'll see hospitals sometimes, they'll install their plans and they'll have a line leak detector on there. And we ask, is this something you really want to do? Because you don't want anything going wrong in an emergency. You want that fuel to be able to get to where it needs to go, keep things going. Okay, so if a double wall pressurized pipe is not programmed for fail-safe or shut off, what's required? 0.1, that's right. Do any of you guys have facilities where they do the 0.1 in lieu of fail-safe and shut off? Yeah, it's not very common, although, that's the actual regulation. Okay, you ready for the good stuff? VPH? Who's familiar with that term, VPH? Oh boy. Okay, like I said, this is a beginner's class. I did want to touch on this because this is a type of monitoring that's been required since 2004. So here we are in 2013, so we should all be a little bit aware of this type of system. But you can go into a lot more detail than I'm going into here. But hopefully this small overview will bring you up to speed just a little bit and get you more familiar. Okay, so otherwise known as vacuum, pressure, or hydrostatic monitoring for a UST. Okay, so the bottom line is you're looking at continuous monitoring, but in a different way than you would for secondary tanks or secondary piping. Your options are that you're monitoring that interstitial space with one of three options. You have the option of doing it under vacuum, under pressure, or hydrostatic. Okay, which basically is what it sounds like. You're having a tank and your pipe is completely filled with some sort of interstitial fluid. Interstice, right there. So that space, that's the space, either vacuum, pressure, or liquid filled. Okay, so the intent is that you're detecting any sort of breach, whether it be liquid or vapor. Okay, and additionally, it's meant to detect water intrusion coming in from the outside of into the interstice as well. I just threw this up there to show you, especially those of you that might do any sort of plan check with these types of systems. The state has put out this nice graph. This is also on the state website, and this is you can find it under piping matrix, and they continuously update this as new brands come onto this list. But this is a basic list of all the brands and their sizes that have been approved for vacuum, pressure, or hydrostatic monitoring. Okay, and the thing to realize is that this is for non-metallic piping. And then this section right here will tell you which application it's been approved for. So you'll notice that not many of these brands have been approved for hydrostatic monitoring of the piping. The tank is not so much an issue, but it's rather the piping. And there's very few sites out there that I've seen that actually have their double wall piping that's filled. So maybe one or two sites. I don't know if you guys are more familiar, but we've seen that only with the Amron brand, which makes sense because it's the only one that's approved. So, Okay, so another handy dandy table. This is from that same document that I was using the other two. This is page 7, and this is going to really break down those tanks that were installed post July 1st, 2004, okay? A lot of words on there, so I've kind of broken each one down into a sentence just so hopefully it brings a better visual and you know what we're trying to say. So, option 1. You're basically putting everything under double wall, okay? Dispenser to UDC, everything is double walled. Because we don't see that now. We don't see that in pre-2004 tanks. You have your sumps, you have your transitions where you get the single wall piping as they cross over into the sumps or UDCs, right? So the idea with option 1 is literally double wall from turbine to dispenser, okay? Is that a good visual? Okay, and then something to keep in mind, just as an afterthought, each of these options needs 3.0 gallon per hour line leak detector, which is nothing new. We've always needed those since November 2009 for double wall systems, so that's nothing new. The other thing to keep in mind, though, is even though you have this very stringent monitoring types, you still have the potential for that option 1, you still have the potential to have a leak within the sump or within the dispenser, okay? So even though your double wall piping extends from dispenser to turbine, you still have the possibility of something leaking from the turbine itself or something leaking from the dispenser. So these also require a more traditional type of sensor within the UDC or the sump. Okay, but the main new requirement is that you're looking at your double wall piping that needs to be continuously monitored by VPH dispenser to turbine. Does anyone have any of these sites with this option? You do? Okay, yeah, they're not as common as some of the other options, huh? No. Okay, so this is a very basic sentence, but it's supposed to really make you think what it is. You're basically monitoring that empty space. So think of a sump. There's a lot of empty space in a sump, right? You're monitoring that actual space. So you're pulling a vacuum on the sump space. You're pulling a vacuum on the UDC space. You're pulling a vacuum on those lines. So which one sounds feasible? Probably the lines, right? Vacuum or pressure, you can isolate those. But can you think of pulling a vacuum on a sump? Every time you access that sump, you're breaking that seal. Anytime you're accessing the UDC, you're breaking that seal. So, but the good news is you don't need a sensor in your UDC or your sump because that space is being monitored by the continuous monitoring. So that's the difference between options 1 and 3 is you don't have that traditional leak detection that sits on the floor, the UDC or the sump. Okay, and then the most common option that's out there, just to break it down, is you have a double wall sump and you have a double wall UDC. Okay, so nothing looks too different from the pre-2004 tanks. You still have your typical double wall piping, but you're still seeing those single wall components within the sumps and UDCs. So your transition sumps are going to look very similar. You're going to have double wall piping below grade. As they get into the sumps or transition areas, they're going to go single wall. The main difference is the actual under dispenser containment is going to be double walled. Okay, is that clear? Okay, so the bottom line, the thing to remember is whatever is touching earthen material is going to be double walled, whether it be double wall piping or the double wall sump or the double wall UVC. So you're never going to have any sort of component that is single wall that's in contact with the surrounding earth. Okay? This is the easiest one to make happen. These other ones I haven't really seen too much of, so that's about it. That's all I've seen. So that's our experience with those. Okay, and then the thing to keep in mind, remember when I was talking about with double wall pressurized piping that you're required to do a 0.1 line test? However, most people in lieu of did the fail-safe and shut-off. So with these new systems, that line test is not required any longer. Why? Well, you're literally continuously monitoring that space. Okay, so here's just a close-up. This is a sump wall, and you can see that it's double wall, and it has that very small interstice there. And like I said, this is what will be in contact with the surrounding soil. So you're going to always have that double wall component. Okay. Just to get a little more detailed, stop me if you have questions, please. So when you have a tank system, they can't put the entire system under one vacuum or under a single pressurized portion. So what ends up happening is that they break the system into zones. So you might have certain components in one zone, and then another couple components in a second zone, so on and so on. So example would be, you might have the 87 STP sump and the 87 vent line in one zone. And what that means is there's one monitoring module for each zone. And this will be a little bit more clear when I get to the pictures. But basically, whether you're doing pressure, hydrostatic, or vacuum, you have set points that if you go above or below, it goes into alarm. But within the set points, it can still fluctuate without it necessarily being a problem. And most often it's the turbine, but there's going to be a source that compensates for the fluctuations. So you're going to see a turbine that's going to kick in when you get outside, or when you see those fluctuations within the set point. It's going to, assuming it's vacuum, let's say, it's going to turn the turbine on to act as a power source to pull more vacuum. Okay, and then same as what we talked about, the hydrostatic test. Your set points are really your high points and low points on your sensor, because it's going to pick up, when it drops and when it raises. Okay, so next slide is going to show an example of a zone, and in this zone, you have your diesel fill sump, your diesel STP sump, and your vapor line. That's all under a single zone. Let's just call it zone 1. So this particular zone is going to have its own sensor module. So let's say it's called, they're designated by S, so instead of the L, like we might normally see with the Veeder-Root. So if S1 is going to be your diesel fill and STP, and that's what goes into alarm, your problem is with this particular zone, because otherwise you would never know where to find anything. And here's just a real-life view of how, it can get very complicated, don't get me wrong, it's complicated, but here's a real-life view of how the different zones can be connected, and oftentimes you're connecting components that are different tanks. So sometimes you strictly have a piping that connects two tanks just for the crossover of that vacuum pipe, just to maintain the zones. Okay, like I mentioned, once again, the zones, and they each have a vacuum sensor. This is making the assumption that we're looking at a vacuum type monitoring. So you have this one zone, really only monitors the supreme product. However, this zone right here, let's call it zone 2, that's going to monitor all of the vents. So let's assume you have an 87, 89, and 91. That zone will take into account that secondary space for those components, and so on and so on. And that's just a close-up of what a vacuum sensor looks like. Okay, here's another view. Often these are in blocks of 3 or 4, and these blocks usually also have these little cups here that are going to detect any sort of water intrusion into the line. It's called a liquid sensor also. And it has the same basic function as a float like this. So it's going to detect water before it gets actually into that interstice. Okay, and then we touched on this already. It's a hydrostatic monitoring, and the point is you're keeping that fluid within your set points being the high and low of your sensor there. And then so like I said, that hydrostatic monitoring was nothing new to most people since 1984. However, this is what's new. I mentioned that to maintain that secondary or that double wall structure, you're looking at double wall sumps, which you saw that picture of, and then here's an example of double wall under dispenser containment, and this one is liquid filled. So it's the same principle as a liquid filled double wall tank, where you have your, you have your reservoir here, and that feeds the interstice with brine, and this has a set point because there's a sensor in here too. So within even this small zone, you're still going to have your set points. And here's another view with the reservoir that's connected to that interstice. Okay, just another view. Same type of pipe as this, the Environ. That yellow line going down the middle is the interstice, and then you've got the two blue lines is your double wall of your sump or UDC, whatever it's depicting here. But you can see with the yellow, the vacuum or the liquid, whatever the case may be, is going all the way up to, in contact with the piping. So you're not having any spaces that are not being monitored. Okay, ready? Want to wake up? 3 methods for continuous monitoring. H? P? Vacuum, yes, VPH. Thank you, guys. Okay, you have a scenario, right? This is just for fun. So if you have a UST system with 3 tanks, associated piping and UDCs, and it was installed in 2001, so this is pre-VPH, okay? If they repipe the entire system in 2012 or 2013, will the new piping require to be under this VPH monitoring? Yes, no? Yes. No. Good effort, good effort. You don't need to change. VPH is contingent on when the tanks go into the ground. So if you're repiping a facility that was installed pre-2004, you just need to meet those previous standards, which, let's say in this case, it was simply double wall piping that had the sump and UDC monitoring. Now, if you had an existing, like say you had this scenario and you weren't doing a repipe, but instead you were adding on to the facility a new tank. So that new tank would have to be under VPH monitoring. And what else? The piping associated with that new tank, right? And what else? Pretty much anything that new tank touches. So if you're retrofitting into an existing UDC, that UDC is also going to have to come out and be replaced with a double wall UDC. Or what some people do is they install the tank separately. It has its own line, tank, and UDC, so the existing system doesn't need to be retrofitted at all. You'd probably rather me keep talking than do this again, right?
Everyone, it's dancing time. Okay, Jeff was our smart individual last time, held his own. I need you to pick a row between 4 and 10, but not 7. 4. Four. Row 4. Come on up, guys. Come on, it'll be fun. You'll get some exercise. A big round of applause for everybody, please. Thank you. Let me shut my music off here.
This is more fun than me sitting up here and talking all day.
And anyone that would like to join them, feel free to come up. Well, this is Alanita. Yeah? Right here, sir.
Thank you.
No, it is Jerry. I thought. Jerry, where are you from?
Contra Costa.
And you are during the day?
Pardon?
What do you do during the daytime?
Hazmat specialist.
Oh, ER. Emergency response a little bit? Tanks. Okay, good. Right up your alley. There's no time. It's fun. Don't feel any pressure at all. Except we got 1 minute.
Okay. Well, you know what? He wasn't here, so we'll just do this one again.
Okay, he wasn't here, so it's practice.
Yeah.
Okay, here we go again.
We're -1 pyramid.
So,
We'll do the first one.
Rust.
The clue is
Rust.
cathodic protection.
Next clue.
Area under the pump island.
Under dispenser containment.
Yes,
Yes.
very good.
A device that alerts us to an overfill.
No, you said overfill. I just thought overfill.
You just got overfill?
A device that alerts us to an overfill.
Overfill alarm, flapper valve, ball float.
I heard alarm, so we'll go with that. Thank you. And I realized
device.
we've done this pyramid before. I didn't want to start the next one because the next one is more applicable to the stuff we're talking about next. So it can't hurt to have a little review and just to kind of, an opportunity for a Starbucks card.
Okay, so we're sticking with the one clue that he gave you. You didn't get it yet. Here's,
No, we're moving on. Yeah, we're moving
on
on
to the next one?
to the last one there.
okay.
Mechanical device under UTC.
Mechanical device.
Mechanical device in a UDC.
Bravo float.
Yes.
Float and
thank
chain.
you.
There you go.
Contains, or 5 gallons.
Spill bucket.
Yes.
Bill Bucket.
It's a monitoring probe. It's a sensor.
Yes.
He's too fast.
Woo!
Prevents overfilling a tank.
Overfill prevention device. Automatic tank. Overfill alarm. Ball float.
Ball flow. Or 2. Christmas time. Let's reuse some of our clues.
And the year before 1999.
So Christmas time pre-89.
She said the
Oh, I'm sorry,
Christmas month
pre-99.
and the year before 1999.
Christmas month. December 22nd, 1998. 1998.
Wow, he even gave the exact date. Bonus.
It's a type of ATG. It's not a ball float.
Mechanical.
Type of ATG, not a ball float.
It's more a type of overfill.
Overfill, it's a flapper valve.
It's a flapper.
Thank you.
The blank space in between the primary and secondary containment?
Interstitial
Thank you,
space.
thank you.
Very good. Thank you very much, sir. Thank you for your effort. Thank you, folks, for coming up.
This is UST Monitoring Certification. This would be the annual testing that all UST systems are required to have annually, or the regulation says every 12 months. Does it have to be in a particular month on the year? No, it doesn't. Well, if it's done in February, then it's supposed to be occurring again the next February. Unless for any circumstances, the UST Monitoring Certification ends up being done earlier, or let's say you were due every July and now you had a cold start and and you had to reprogram your monitoring system, then you have to run the certification again. Maybe now you have to do it on March, and it would be up to your local CUPA to move up that annual testing. Maybe they would consider that only part of the final inspection as a cold start, like a plant check inspection, or maybe they decide, along with the UST owner, to now reset the annual date on the testing. The annual monitoring certification has to be completed according to manufacturer's instructions. This is in regards to all the components, piping, the tank, the dispensers also. And similar to what I was saying before for the spill containment, also every time there's a test in the UST system, the CUPA agency has to be notified at least 48 hours in advance. But now usually with the monitoring certification of the tanks, since we regulators also are on site during the inspection or during the testing, we just schedule the inspections with the contractors or the technicians. So that would be, it's not like an official notification because we are involved in the scheduling process, but that would be considered the requirement, that would meet the requirement for the early notification. And once the test is conducted, technicians, the certified technicians, have 30 days to send us a copy of that result. Not them, it's responsibility of the UST owner or the UST operator. But most of the time, they are in an agreement that the technician who's running the test, he's gonna certify it and he's gonna provide a copy to the owner and also to us. It just makes it easier for the UST owners and operators. Now that's a photo of an actual testing going on. During that photo, one of our inspectors is actually training some other new inspectors. And as you can see, there's some, is this a laser? Yeah. We can see here all the sumps. This would be the field sump, all those on the back. The sumps on the front will be the turbine sumps. And how do we know that? Well, because here on the field sumps, all these manway leads, they have 2 circles here. That would mean that those are the leads for the buckets, the spill containment, for the field riser and also the vapor. Yeah, that's what I was saying. That was the field sumps, and this is the turbine sumps. The other small leads here on the front, that will be for the annular spaces. So that's a good overview of what we regulators see. Maybe if we were just regular customers and we were not trained on this, we just see leads, and if we see any leads, because maybe we don't even pay attention to that. Here, everything is open for the inspection, and for the testing, and for what I see, the inspector is looking this way. This is a dispenser, and I'm assuming that the technician is on the other side. Maybe he's inside the store running a fail-safe or one of the other testings that, like sensor out, that the inspector is communicating with the technician. And that was like a funny joke. How many CUPA inspectors does it take to complete an inspection? Just one, right? But remember, this was a training, so there's 4 people there learning from the inspector. Now is secondary containment test. Well, secondary containment components started to be tested after 2001. And that's for all new systems, and for all systems that were already in place, the secondary containment test was required by 2004. Now the testing is required at the very beginning for new installations, 6 months after, and also 3 years thereafter. And this would be also for if the new if a system is installed, and then you bring another component like the new tank that Cecilia was talking about, that you bring, well, not the new tank, the new piping that you bring, that has to be tested at the installation, and then 6 months later, and then 36 months after. And most of the time, it's very convenient for the UST owners and operators to just have everything at the same time. So he doesn't have the UST system that it's already in place running a secondary containment test at one time, and then the other section, like the new piping, at a different time. That's just kind of messy to have different schedules within that same UST system. And what's included in what's part of a secondary containment system? That would be all the secondary component, the secondary wall of the tank. That would be the UST itself, the sumps, as I was showing, the field sumps and the turbine sumps, the piping for double wall piping. It doesn't matter if they are fiberglass or flex lines, and also for under dispenser containment. And again, it doesn't matter how the UDC is being monitored, either electronically or mechanical. All dispensers, the under-dispenser containments are secondary containment. Are spill buckets secondary containment? Yes? No? No, they are not. But they also, most of the time, they're tested at the same time as the secondary containment test. This photo is just showing, this of course is during a construction. All these are new sumps. The turbines are here. This will be the other sumps for the field. And this will be for the ATGs. I wasn't there. All this piping, and this is just to show what would be a lake test. Here, like we can see here, they're filling up this one with water, so they're gonna run an actual visual hydrostatic test. And what's gonna make it visual and effective would be that we are gonna be able to notice any difference on the levels of the fuel, on the liquid, on the water here, because we can see the inside of the sump and we can also see the outside of the sump here. And we can see the surroundings around the sumps. And that's what I was mentioning before about spray painting on the top, on the surface of the water here. So if this containment is actually leaking, we're gonna be able to see the water, the level of the water here, just dropping. So that's not fancy, but it works. And do you think we're gonna be able to run the same test 6 months after? Probably not, because maybe if this place is going under construction, maybe within 6 months, everything is gonna be backfilled already. So we're not gonna be able to run a lake test like this, because remember that we have to see all around, inside and outside. Now, at the 6 months, since everything is covered on the outside, technicians are gonna have to run like with a precision test with an Incon in this case. And that's a sensor that I was referring to earlier. This is a float, this one, white one here. And I don't know if you're able to see here, there's another section here of the probe that is gonna allow this float to move either up or down. And again, you have the water here for testing. Now, how high are technicians supposed to go with this water? How much water do they need to put in? 2 inches above the highest product line. Would that include, well, I just said product line, but I was gonna ask if that would include electrical lines, for example. Do they have to cover those penetrations too for electrical conduits? No, they don't. So it's 2 inches above. If they wanna go beyond that, that's up to them. Yes? She's saying that she has heard that from some technicians that they have been asked to actually test, including the penetration for the electrical conduits, and she's asking if any other jurisdictions or any other CUPAs have that that requirement. Do you know of it? Nobody? Did he say what state? Oh, within the county of LA? It is not a state requirement. It might be a local, like a CUPA, a local jurisdiction requirement, but none of here. At least none of those here. And I know here is San Mateo, here is San Diego, here is, who else is here? I don't know, that would be something that goes up to the local level only. He's saying that if the system is required to have positive shutdown, it's recommended that the sumps get tested all the way up. But it's not a requirement. Is that what you said? Yeah. No, it's not required by law. It might be by ordinance, like by the local ordinance. Now, also, under dispenser containments, they are part of the secondary containment. And here is just showing a photo of the equipment that, again, the Incon, and I'm not sponsoring Incon, but that's the most common that we see out on the field. And this would be the machine where you actually get the readout, the printings and the readouts of the levels. And this is the cable that goes connected to the flow that I was showing earlier on the sump. And remember that this test has to run twice at least. We need 2 consecutive passing results, and each one of those being 15 minutes. And if you have the first test passes and then the second one fails, you need to run 2 tests again because you need 2 consecutive ones, okay? And that's how it should be on a normal basis. You have the piping, double wall piping, and you have the boot here pulled back. Now during test, this boot has to be pushed over here, blocking the secondary containment. So the secondary containment in the piping can also be tested, usually with pressure or vacuum, either or. But that should be the normal way. When you open a sump and you want to see the regular status and to see if it's in good conditions, that's what you need to find, a boot pullback. If it's blocking, that would be preventing any release from the primary line in reaching the sump. So if there was any leak from the primary line to the secondary, that sensor in the sump wouldn't be doing anything, right? Because this boot would be blocking any leak. Now, systems that were installed on or after July 1st in 2004 and are continuously monitored via vacuum or pressure or hydrostatically, they are exempt from secondary containment test. And this is because they are being continuously monitored. So they don't have to run the secondary containment test every 3 years. Any question on secondary containment? Okay, so moving on with enhanced leak detection. This is a test that it's more precise than any other test. It's more precise than the vacuum test or than the secondary containment test. And it determines the integrity of the UST system by adding a substance that is not the same that is being contained in the tank. This is called a tracer. And they add it to the tank, and they have to monitor if that substance actually leaks from the tank to the surroundings. This being the ground on the outside, or any water outside, like groundwater. And I'm going to show you on drawings here how it works. So first, in California, there's only 3 companies that are certified to run the ELD test, or enhanced leak detection test. And what they do, they actually go to the site, they go to your UST facility, and they check, and I don't know their specifics, but they decide how many probes they need to drill here around the tanks. How many probes, and for that, I don't know if with all CUPAs, but they would need a permit with their Land and Water Quality Division. Then the technician comes and he inoculates the substance that I was telling you, the tracer, which has to be an inert material. And remember that nothing that is already stored in the tank. And here we can see the difference, like the fuel in this case is yellow and the tracer is, just to give you to differentiate one from the other. So he comes and inoculates that substance here in the tanks. And then he has to let it sit in the tank and mix with the fuel being contained in the containers in the USTs. And then he goes back, and now he accesses those probes that he drilled before, and he has to take measurements. So he's going to take samples, and he's going to see if any residual of that tracer that he inserted in those tanks actually left the tanks. Now, these readings that he gets here, that can be either from liquid, in a liquid state, or on a vapor also. It's that specific that it can detect also vapors, not just liquid. Now, who's required to to have an enhanced leak detection test. Well, all single-wall USTs that are located within 1,000 feet from a drinking water well system. And this has started to be implemented in 2000. Now, the ELD test, similar to the secondary containment test, has to be completed every 3 years. Now, all double-wall USTs that are located also within 1,000 feet from a drinking water well, they also have to be tested for enhanced leak detection. The only difference, though, is that double-wall tanks have to be tested only once, and tanks that are single-wall have to be tested every 3 years. 3 years. And this wasn't required by 2003. If you already had a double-wall tank that was in place, the state was actually notifying all facilities that, per the knowledge of the state, were close to a drinking water well. They received a letter saying that you have 18 months or 3 years to run this test and send us the results. So those results for ELD tests, those have to be submitted to the local agency as well to the board, to the State Water Resources Control Board. And that was quick. When is secondary containment testing required? Every 3 years. Since when? Yeah. Oh, I thought he was going to give me the date. It's upon installation every 6 months after. 6 months after the installation and 36 months afterwards. Now, if you are within 1,000 feet. Now, if you are within 1,000 feet, you have a single wall system, you have to run the test every 3 years. Now, for that test, the facility also has to implement an ELD test plan. It's not just, I'm going to run the test. You have to have the UST owner, along with one of these 3 certified companies, they have to come up with a plan and design how they're going to be testing, how they're going to be running that ELD test. And that plan, they also have to provide a copy to the local agency. And I think that would be it. Now it's turn of Mr. Ken.